When you need to supply a DC voltage to an electronic device, such as a solenoid, that will be under control of an electronic circuit, there are two choices for control, known as source and sink. Let's first consider the following items: a power supply, a DC solenoid, known as the load. The power supply takes AC voltage from the wall outlet and converts it to DC for powering our solenoid. When the solenoid is not powered, it sits in a relaxed state with its spring-loaded plunger extended. When we connect our power supply to the solenoid, a magnetic field develops in the solenoid and retracts the plunger. Next, we will add a microprocessor, which will be used to make decisions as to whether the solenoid should be powered or not. The microprocessor has voltage output that indicates the state we want the solenoid to be in, but its outputs cannot supply the high voltage and current needed to power our solenoid. Because of this, we must also add a transistor to be used as an electronic switch. So now we encounter a dilemma. Do we break the connection between the solenoid and the power supply at the positive side of the circuit, or the negative side of the circuit? Either way will give us control we need, but one will suffice. If the transistor controls the positive side, it is set to source power to the load, and if it controls the negative side, it is set to sink power from the load. Remembering the difference between source and sink is easy if you think of the current supplied by the power supply in terms of conventional flow, where the current comes out of the positive side of the power supply and goes into the negative side. So then, a transistor that sources the power is providing the positive voltage to the load while the negative side is connected directly to the power supply, and a transistor that sinks the power is providing the negative voltage to the load while the positive side is connected directly to the power supply. So you might be asking yourself at this time, if both work equally well, why might you choose source over sink? The primary trade-off is between performance and safety. Transistors that drive sink tend to be able to handle higher currents and operate at slightly higher frequencies than source transistors. However, when a sink transistor is turned off, a short to your load to a surrounding housing that may be grounded will energize your load. That is to say, there is always power on the sunk load, whereas the sourced load, being always connected to ground, will only have power at its terminal when commanded by the control circuit. We at PONTECH hope this short video helped improve your understanding of source and sink. Thanks for watching. Smiley face.